Hello everybody, we're going to be looking at part 2 of yesterday, which is talking about parallelograms. And what I'm going to do for this video is I'm actually going to show you a couple more examples of what we've been doing, but this time I'll use the theorems a little bit more, just so that you can see. So when you look at this particular example, it basically is asking for figure out what x is. It doesn't mean anything else, it's exactly that. Now in order for us to figure out what x is, we have to know what type of a polygon this is. So if we know the number of sides that it has, then we know exactly the total amount of the interior angles, right? Because even though we know what it says x plus 10 plus 120 plus 140 plus 100 plus 98 plus 155 is going to be equal to what, right? We don't know what that what is. So in order for us to figure out exactly what that is, and I'll put a question mark on it right there so that you can see, well, we have to know the total amount of the interior angles of a polygon. Now if it was a four-sided figure or a four-sided polygon, then it would be easier for us to understand that we set it 360, right? However, this one, if we count, we have 1, 2, 3, 4, 5, 6. So we have 6 sides. Yesterday I went over the formula. Remember, the formula says you have 180 times n minus 2. Then it's going to give you the total, right? The total amount of the interior angles for that particular given polygon. So having said that, we already know what n is. N for us is going to be, right, the number of sides that we have. So it's going to be 180, and then it's going to be 6 minus 2, so we get 180 times 4, which will give us a total of 720. Now I know exactly what I have to equal this to, so I'm just going to go ahead and substitute it to the right hand side, and I'm going to put that it's 720. Now I'm going to combine things that are alike, so all of these that are just numbers, I'm going to go ahead and add them up to make it easier for you to understand. So we have 10 plus 120 plus 140 plus 100 plus 98 plus 155. That it comes out to a total of, so we have x plus 623, which is equal to, again, 720 is the total amount of the interior angles. And this is a one-step equation where we get to use the subtraction property of equality. So we get to subtract 623 from both sides. And in doing so, that simplifies, and then we're left with x that is equal to 97. So x is 97 degrees. Again, remember, always go back to see what it says, because sometimes we could also ask you, okay, now that you know what x is, what is this particular angle, right? So then you would have to substitute x in here, then add 10 to it, and figure out what that last interior angle is. So there are multiple ways of doing this. You just got to be aware of what's being given to you. Okay, so this one again says find what x is. Look at where x is located. X is not in the inside. This right here is called the inside, right? It's actually an exterior angle. We know something unique about the exterior angles, and I kind of went over it yesterday or in the last video, that it talked about that no matter how many exterior angles you have, they will always equal to 360. So remember that. So I'm going to still add them up. So I'm going to get x minus 7 plus 72 plus 80 plus 65, and then I'm going to equal it to 360. So now we combine things that are alike. As you see, all of these are numbers that we get to go ahead and add together. So we end up with x plus 210 is equal to 360, and then we use the subtraction property of equality to be able to solve for x. So we're left with x is equal to 150. Don't forget it's degrees, so you have to put that little circle on the top. Again, with this one, I could also ask you, okay, so now that you know what x is, go ahead and substitute it in here, and then give me exactly what the exterior angle, which will be this one right here, what is it going to be, okay? So there are multiple ways of me asking you the same question. I'm just going to always either ask for x, an interior angle, because I could also ask the interior angle, and the way that you will solve for the interior angle is you have to know the exterior angle first, then go 180 minus whatever this is, and then you're going to get this interior angle here, okay? Remember, we can be very tricky, and all you have to do is be able to understand what it is that we are trying to ask for, okay? So let's continue on to the next one. It says find the value for x. Remember, when they give us the word parallelogram, we know a lot of things. We know that these two are parallel, opposite sides are congruent. We also know that opposite sides are congruent, and we know the most important thing, that diagonals bisect each other. Remember what the word bisect means for us? It means that it cuts it right in half, and we know that these will be congruent. All of this is what we talked about in the last video. So if you look at what we have, we basically have the left hand side, the line segment on the left, that is going to be congruent to the line segment on the right. So we are basically just going to set them equal to each other. So we have x minus 9 is equal to 20. Okay? And then you use the addition property of equality. Simplifies to 0, and we're left with x is equal to 29. And this is not degrees. This is 29 units. I think in the last video I emphasized that a lot. I'm sorry for that mistake. But again, remember, units can be inches, it could be feet, whatever it is that I'm talking about for that particular one, okay? Here we go. We're going to try to figure out exactly what x is, and it is a parallelogram, so I'll go back to the last example. And if you look at it, I marked it everything. What they're giving us is they're giving us diagonals. We'll call this one O. So if we look at the diagonals, they bisect at O. So that tells us that this line segment is going to be congruent with this line segment. So we end up with 2x that is equal to 16. I get to divide both sides by 2, and I see that x turns out to be 8. And it's 8 units. Okay, it's 8 units. Which is good for us. The next example, again, look at what it's asking. It's saying, look, I want you to figure out what x is, and this is a parallelogram. If it's a parallelogram, remember, we go back to what we drew here, and it tells us that opposite angles are going to be congruent. So that's what I'm going to do. I'm going to set this up where I have x plus 23, that is equal to 60 degrees. I use a subtraction property of equality. That simplifies to 0, and I'm left with x is equal to 37. And this is degrees because we're talking about the comparison of these two angles, okay? Very easy, I know, but sometimes you always have to take a step back and realize what is the piece of information that they are giving me, right? And I'll highlight it here for you so that you can see this is what they're telling you, that it is a parallelogram, okay? That's what they're telling you. It is a parallelogram. Again, we're looking for x. They tell us that it is a parallelogram. That's very important for us because now we can say the following. So look at what we have. We have two interior angles. It is a quadrilateral, so we know that they are equal to 360 degrees. However, I'm only giving you two angles. And because they are consecutive, we know that we are going to add them. and we are going to set them equal to 180 degrees, not 360. 360 is if we had all of these, and I'm adding all of them, remember, all the angles. But because I only have two of them, which you can see here, I only have this one here and I only have this one here, that tells me automatically that I am going to set them equal to 180. So I just combine things that are alike. So it's going to be 3x that is equal to 180. I get to use the division property of equality, where I get to divide by 3, and I end up with x is equal to 60 degrees. Okay, 60 degrees. Super easy. It's not that hard. You just got to take into consideration the things that they are giving you. What is it that they are giving you? Okay, so this one here is pretty challenging, okay? And the reason why I say it's challenging, because I imply here that it is a parallelogram, okay? And with a parallelogram, there has a lot of properties that you need to look at. So 3 of the vertices of a parallelogram, so if you look at it, you follow along, it says 3 of the vertices of a parallelogram, A, B, C, D are given. So 3 of them. A is given, B is given, and C is given. It says find the coordinates of point D. This is what I want to figure out. In order for us to do something like this, we have to plot the first 3 points that they give us. So I'm going to look for A. A is located at 3, 6. So I have 1, 2, 3, 1, 2, 3, 4, 5, 6. That's where A is located. B is located at 6, 7. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. There it is. That's where B is. C is located at 6, 3. So here we go. 1, 2, 3, 4, 5, 6. And it's 3. 1, 2, 3. So this is where C is located. We are going to now connect them. So it's going to go from A to B. Okay. And then we are going to go from B to C. And now you're going to start seeing there is no way that I can put D somewhere out here because it's not going to make any sense, right? We're looking for a parallelogram. And if it's a parallelogram, it's a quadrilateral. That means it's 4 sides. It has to be somewhere out here. We just don't know where it is, okay? That's the problem that we have. So how do we figure out where D is going to be located? Well, we know something unique about a parallelogram, right? We know that if we were to have a parallelogram, let me draw one really quick. So here we go. If we know that we have a parallelogram that looks like this, it's not going to be perfect, so just bear with me. We know that we have parallel sides. We also know that they are congruent. So let me do that in a different one. So we know that this is going to be congruent to this, while these two are going to be congruent to one another. We also know that opposite angles are congruent. And we know that the diagonals, okay, we know that the diagonals here are going to bisect each other, which will create congruency of all the smaller line segments. So that's very important for me because I'm going to take that information of having this side be congruent to this side here. I'm going to take that into consideration. Now, if I can figure out the slope of this side, I can mirror that slope and use it on the left-hand side. So that's all I'm going to do. I'm going to basically figure out exactly what the slope is. And if you look at this, this is a vertical slope. So I have 1, 2, 3, 4. So I went 4 units down, straight down. So I'm going to take that into consideration, and I'm going to do that the same thing, okay, from A, to be able to figure that out. So I'm going to have 1, 2, 3, 4. And that's where a D is going to be located for us. It's going to be located at 1, 2, 3, 1, 2. Okay? to be able to figure out exactly where it is. So I'm just going to connect them. I'll connect them with a different color so that you can see. So I'll use purple. I'm going to go from C to D. Let me erase this really quick. And then I'm going to go from D to A. And there's my parallelogram, okay? And again, what I'm looking for is the coordinate plane of this. So what I'm looking for is whether they intersect. And again, they intersect at 1, 2, 3, comma, 1, 2. 3, comma, 2. Okay, so let's continue on. What I'm going to be looking for now is, again, figuring out what x is. We know something unique about this, and because they give us right here, they give us the basis of this trapezoid, that these two bases are congruent. And if they are congruent, this is an isosceles trapezoid, which is good. What is it that we want to know, though? What x is? Where is x located? X is located here. So this 12 that you see here is really not helping us out. As a matter of fact, it's just getting us a little more confused as to what we want to do. So we just put that to the side. We know that this is going to be congruent to this side according to the trapezoid, remember? We did that yesterday, or in the video, on the last video that talked about trapezoids and isosceles trapezoids. So I'm just going to go with x plus 11, that is equal to 17. And I use the subtraction property of equality, where I get to subtract 11 from both sides. And I end up with x is equal to 6. 6 units. Okay, super simple. It's not that hard. If I wanted to know what this angle would be here, I would have to know at least this one here, or this one here, or both of them. And then remember, these two are supplementary to each other, so I can figure that one out, okay? So keep that in mind. And here's another example. Again, we want to figure out what x is. We know that this is a trapezoid. We don't know if it's an isosceles trapezoid, but we do know that it's a trapezoid, so I can take this angle and I can add it to this angle and then set it equal to 180. So we have x plus 129 that is equal to 180. And all we want to do, again, we just want to use what we know, which would be the subtraction property of equality, where I take 129 and I subtract it to both sides. So I end up with x is equal to 51. 51 degrees is what x is. So down here will be 51 degrees. Let me move on to the next one. Again, I know that this one here was a hard one to understand. It talked about using this midsection that you see here. Remember this trapezoid, if it has MN as the mid segment, I should say, these two are congruent to one another, and these two line segments are congruent. So we could trick you on this and try to figure out, or maybe we can give this to you in the test, in the sense of that's the information that I'm giving you, and then I want to know exactly maybe what this side would be. Okay, so you just have to remember what is the most important thing, or what is it that exactly that I'm giving you. So the formula for this is going to be Mn, remember, Mn is equal to 1/2 times base 1 that I called plus base 2. Remember, this is your base 1, this will be your base 2. Mn, so that's the line segment that we have. There it is. So what is it that you want to do, or what is it that you have to do? Well, you take 12, set it equal to 1/2 times 10 plus 2x. And that's all you want to do. My suggestion, I know that the video that I showed in class talked about multiplying by 2. Just take the denominator and multiply it across. So you'll end up with 24 is equal to 10 plus 2x. Use the subtraction property of equality. Make myself some room here. I get to subtract 10 to both sides. So I end up with 14 is equal to 2x. I get to use the division property of equality here, and I end up with x that is equal to 7. So 7 units. Okay? You have to know this formula. I'll highlight it. This, on the test, we're not going to be able to give you that. So you have to know how to use that. I could also manipulate it and give you something else. Let me go back to this one. I could basically, I can give you everything else, and then I can ask for, well, what is base 1, for example. Let's say that base 1, I don't give it to you, and I want to know what that is. Remember, you could still do it. You just got to learn to manipulate the equation and then be able to figure out exactly how to get base 1 by itself. Pure algebra is not that hard. So here's a good example, just like the last one that I was talking about. Look at what the pieces of information that I'm giving you, and you notice that I give you base 1, the mid segment, and I give you base 2, and then I also give you the sides. There's something unique about these two sides, right? The ones that are in yellow, highlighted yellow here, that doesn't help us at all because none of them have x in it. So what we want to focus on is going to be 4x and 8. And what do we know about the legs of a trapezoid? That these are congruent. So we get to set them equal to each other. So we have 4x that is equal to 8. And now I get to use the division property of equality. Simplifies to 1. 1 times x gives me x, which is equal to 2. And it makes sense. If I substitute 2 in here, I get 8. And isn't 8 the same thing as 8? So that's another way of figuring this out as well. Okay, remember the properties. The properties are the ones that are going to save you on this. Now, looking at what you have here, let's try to name these. That's what I'm asking you to do here. So let me put this down a little bit. Let's try to name the figures that are given to us. So we know that this is congruent to this. This is going to be congruent to this, those line segments. And that's all they give us. And I think that that's enough information for us to try to figure out exactly what it is. This one, 25, we're going to call a kite, right? We're going to call it a kite because we know that the two smaller legs are congruent and the two larger legs are going to be congruent. Let me go on to 26. 26, we know that we have parallel sides, 90 degrees, okay? And we have another set of parallel lines to it, okay? So we have two sets of parallel lines. If we only had that piece of information, then we can say that they are going to be a parallelogram, right? But here we don't have a parallelogram. All we have is that it's 90 degrees and two lines that are set parallel, two parallel lines, okay? So we don't know that yet. Process of elimination could help us here, but we'll try to figure it out afterwards, okay? So I just want you to take into account what it is that you have here. So let's continue. So 26, still a little iffy, right, as to what it is, but it turns out that it's a rectangle. So this would be a rectangle, right? So the next one, look at the information that's being given to us. It tells us that we have sides that are parallel, and we also have diagonals here. Let me go ahead and put them red. They bisect. They're unique because they do bisect one another, but then they give us another piece of information, that this and this right here. So we have vertical angles, and then because we have vertical angles, as you can see, let me put it in a different color maybe. These two will be congruent, and then these two would be congruent. We know they're supplementaries, they create 90s, and that will help us because then we can call it a rhombus. Then the last one will be, if you look at it, a trapezoid. Super easy, not that hard. You just got to be able to look at what's being given to you. Trapezoid, remember, you take consecutive angles and you go ahead and add them and set them equal to, again, 180, right? this last one here, what we have, if you look at it, and it's a kind of a given, right? That you have a kite. This is what it is, and it's good for us because we know that this side is congruent to this side, so that AD is congruent to AB. We also know that DC is congruent to BC. That's good. We also know, because of a kite, that angle D and angle A are going to be congruent, and that angle A is going to be by itself, and that angle C is going to be by itself. However, the addition of all four angles are always going to add up to 360 degrees. So let's see the information that's given to us. It says, in the kite shown, okay, to the right hand side, as you can see, it says measurement of angle, this should be angle by the way, A, D, C, so we have A, D, C, that's 105, so this one's 105, so angle B is also going to be 105, which is good for us. And then it says, and the measurement of angle DAB, so DAB, so D, follow along, A, B. Okay, so this is the angle that I'm talking about. I'm talking about angle A. Angle A is 100, which is good. Now I know three of them. All I have to do is figure out what is the fourth one. Basically, what is angle C? So it's asking us, find the measurement of angle DCB, which is down here. Perfect. We know how to do that. We take the addition of all the interior angles. We'll label angle C, we'll label it to X. Then we have 105 plus 105 plus 100, and we set it equal to 360 degrees. So we add this, so we have X plus 310, that is equal to 360 degrees. Use the subtraction property of equality to be able to subtract the 310 and figure out exactly what X is. What is X? That simplifies, and we end up with X is equal to 50 degrees. So the measurement of angle DCB is equal to 50 degrees. That's it. I think that was it. Yeah. So these are all the examples that I wanted to talk about in this last video. I hope that it has helped you visualize how to use all the parallelograms properties. I encourage you to watch all the other videos. Please continue to watch them until you actually take your final. Okay. Have a good evening. Bye.